A very good day, dear students. I'm Somadeep, your faculty for robotics, as you know me already. So let us begin with our today's session. That is session number 22. Okay. This session is going to be one of the most important session. The reason why I'm saying this, now you might be wondering that, sir, you say this often for many sessions that this session is going to be one of the most important sessions. Yes, I do say that. The reason behind that is that whenever you are writing a code or whenever you are writing a program in anything, okay, there are certain factors that need to be considered, or there are certain factors that need to be there. Okay, what are those? Number one is how you are structuring your code. Like, what is the basic structure of your code? Okay. Number two is what is the intent of your code? Intent, by intent, I mean the purpose. Okay. The purpose of the code. Like why you are writing. You need to always keep that in mind because your processor or your controller does not know that. Okay. So there are certain format by which you can make them know what is the intent of the, like whether you are trying to follow a black line, whether you are trying to follow a white line, whatever it is. Okay, whether you are trying to follow a light, whether you are trying to read the temperature, whether you are trying to uh, you are having an ultrasonic sensor and you are measuring the distance between an obstacle or anything, whatever the intent may be, whatever the purpose may be, you need to make the controller or processor realize about the intent, right? So I should have told this in the as the first point and the structure as the second point. Why? So first, if your intent is clear, then comes the part where you need to structure your code properly, right? You need to give a proper start. You need to include all those libraries if not there already. Okay, you need to uh, initialize the code. You need to initialize the functions. You need to initialize the data types that are being used over there. So everything need to be initialized properly. Then you need to declare the input and output, especially the output where the like we used to declare no like digital write output, which one is the output, the pin config, the pin number and the output, like this we need to declare them. Okay, we need to assign the comparative value of, for example, if you are taking integers, if you are taking characters or whatever we are taking, we need to start that, we need to introduce that. So all these introductions and everything, and then comes the part where we need to write the actual conditions, right? So the actual conditions need to be written over there. In what conditions we are trying to run the code and everything. Okay. So these things need to be taken care of. And finally, in the previous class, also in the previous session, I have made you learn about how to give the conditions, the if statement, the else or else if statements. So everything need to be considered. Now, why this class is going to be one of the most important class for you? Because in this class, we are going to learn something called the for loop. Okay. So what is a loop basically? A loop you have seen in Arduino code only. A void loop. Inside the void loop, we write the code that need to be run again and again, right? That need to go on a loop. So a loop is considered a circle that the starting point is the ending point. Okay. So it will run again and again from start to end, from start to end. So it will run again and again in a complete circle. Okay, right? That is basically a loop. Okay. Now let us see what is the meaning of a for loop, okay, and how we can use it basically. Let's see some of the examples I have provided here also, and let us see how to use it. Usage, the user of for loop is very important. Why? Because uh, when you come to know about the projects and about the code, about the conditions we used to give inside the parentheses of for loop, you'll get to know why it is very important. Okay, so let us begin. Let us read it through. The statements inside the curly brackets under the for loop, they are executed repeatedly according to the specified condition. So whenever we are initializing a for loop, if you can see, this is the structure. This is the whole structural syntax, how we initialize the for loop. Okay. So we write for, that means the for loop has been initialized. And inside this parentheses or inside this first bracket, we write three things. Okay. Three very important things. You need to remember this. Number one, initialization. Students, the word initialization itself means starting. Okay. Starting of something. So from where our loop will start working, we give that condition at first. Okay. So after we give that condition, what is needed? That for running the code, there must be a condition that we are following or that we are trying to follow. What is that condition? That is the second thing. And now how the loop will increment or how the code will get incremented or decremented also. You can say like the minus thing is also there, but we will consider it as increment and negative increment. Okay, that's why it's written as increment. So how are we initializing? From where the initial value starts? What is the condition of running? And number three, what is the condition for increment? How it is getting incremented? Okay, how it will go on and on. These three things are to be considered. Okay, now see, an increment counter in the for loop is used to increment or decrement the loop repetitions, as I said. Okay. The name has been given as increment, but that doesn't mean it will always increase. It can decrease also from the previous value. It depends on the condition. It depends on the intent or the purpose of the code that we are running, that we are performing. The for statement is commonly used for repetitive tasks or operation or to operate on the group of data or pins in combination with arrays. Okay. So this is how the for statement is being used. Okay. So obviously, since it is a loop, it's a loop structure. So it is used for repetitive tasks. That's for sure. Okay. Repetitive tasks. Or we can also operate on the group of data or pins in combination with arrays. I hope you have understood this part. Okay. Till now, it is clear. Let us move on. Number one, initialization. Now, initialization is defined as the initialization of the variable. So, for example, if we have to, for example, there's a famous thing we take as a I, something like that. We take for loop. So, for example, we have initialized the value of I from I equal to 0, right? So, what does that mean? That means whatever condition we are running our code or however we are incrementing the code, I has to start from 0. We can say I equal to 11. That means I has to start from 11. Now, if we, okay, I'll tell you later. I'll tell you later. For now, just consider, just try to understand that initialization means from where we are initializing the value or the value. Okay. Number two, condition. Now, what does the condition means? See, these are very simple language. The fun and the interesting part is they are depicted, they are told to us in a very simple language. By reading the term only, 90 to 95% of the work is done. When you are reading a term called initialization, of course, you know that it is initializing something, right? What it is initializing, that you need to know, or that you need to remember. So more than half, near about full work is done only by reading the name itself. Okay. All right. Second is condition, number two. So the condition is tested on every execution. So condition is something which is being tested in every loop, like in a loop, every time it is running, it is being tested. If the condition is true, it will execute the given task. The loop ends only when the condition becomes false. So that means the condition for the loop to end is making the condition false. Okay. If you remember, when we were discussing if-else statement, they are also conditions, right? Okay. So there also, what we discussed, if statement, if the condition is true, for if statement, if the condition is true, it will run until the condition becomes false, right? So this loop basically does that job. Okay. The loop will end only when the condition will be false. If you are still having any doubt that what I am saying, how this actually works, do not worry, absolutely, because we will be having the coding examples. That is why I am saying continuously that the examples or the code examples are the most important things in case of learning how to code. Okay. Next is the increment. Third part, last but definitely not the least, because this is that part which keeps our code on, which keeps our code going on. Okay. What is that? How is that written? Let us see. Let us check it out. Now it includes the increment operator, such as now operator. I think I don't have to tell you again about the increment operator. So I plus plus, I minus minus, or I plus one, I minus one, this kind of thing. Okay. Generally in every code, you can see I plus plus like this. Okay. It is incremented each time until the condition remains true. So the condition has to be true for the increment also to happen. Once the condition becomes false, the increment stops. And that is how our code ends. Okay. Try to understand our loop ends basically. Whenever it is seen that the condition is getting false, our loop will end over there. Okay. Now, for example, this is how it is written. Okay, this is a very perfect example how I need you to see this or to understand this. I equal to 0 inside for loop I equal to 0, I less than 5, I plus plus. What does this mean? I equal to 0, of course, you know, the initialization is from 0. So that means the value of I, the value that is assigned to I is starting from 0 itself, right? Okay. Now I less than 5. So I less than 5. So that means this code will go on until and unless I becomes less than 5. And if you've started from 0, okay, now try to understand, dear students, try to understand between 0 and 5, there are infinite numbers. There can be infinite numbers, right? There can be 0 0.1, there can be 0 0.001, there can be 0 0.000001. Infinite possibilities of numbers are there. Okay. That means, so our code must run infinite times? No. To restrict that, what we have given, see the increment. We have given it I plus plus. What does I plus plus means, dear students? It means I plus 1, right? So that means from whenever our I is initialized, then it will get incremented on the basis of I plus 1. So that means 0 plus 1 is 1, 1 plus 1 is 2, 2 plus 1 is 3, 3 plus 1 is 4. Now 4 plus 1 equal to 5. This will not happen. Why? Because we have ended the code. Can you see the condition? We have given the condition as I less than 5. Understood? So whenever they will see that 4 plus 1 is getting 5, it will stop over there because that is not true for this loop to happen. Understood? I hope you have understood this. Okay. Now, the above statement will execute the loop for 5 times, of course. One for 0, one for 1, one for 2, one for 3, and one for 4. So 5 times it has been executed. The values of I will be from 0 to 4, as I said earlier. Okay. Now let us change something. What change is there? If the statement says for, and inside the bracket, I equal to 0, that we've started, and the condition is same, the condition is a bit different, I less than equal to 5. So in this case, we are considering 5 also. Try to understand. Very easy to understand. The first code snippet, the first line, we have seen I less than 5. That means I must be less than 5 only. I cannot be 5. Okay, the value of I cannot be 5. But here what we are saying, I less than equal to 5. That means it will run up to the value of I becomes 5. Right? So there are 6 terms. Okay, there are 6 terms. From 0, 0 to 1, 1 to 2, 2 to 3, 3 to 4, 4 to 5. Okay, up till 5 it will run. There are 6 terms. So this was about the structure of for loop. Let us move further. Now to print a message Arduino 15 times. Let us see how we can do that. Okay, we need to print Arduino 15 times. Right, the word Arduino 15 times. Easy. How to do it? See, to print the message 15 times or more, it's quite complicated using serial printer. And of course, like again, see, this can happen. This is kind of the replacement of repeated addition by multiplication. You can write like this, that 15 plus 15 equal to 30, plus 15 equal to 45, plus 15 equal to 60, plus 15 equal to 75. Like this, you can go on and on and on, right? 15 is not important. I'm just giving you an example. Like 2 plus 2 is equal to 4, plus 2 equal to 8, plus 2 equal to 10, plus 2 equal to 12, plus 2 equal to 14, plus 2 equal to 16. Like this, you can go. Or what you can do, how many times 2 is being added, you can multiply it with 2. It will give you the same example, same answer. Right? Okay. So what we can do, we can run a for loop over here. Okay. In place of writing serial.println for 15 times, what we can do, we can implement a for loop over here. Okay. How will it look? See, let us consider the below code. So int I have initialized the code. Int I have taken an integer named as I. Then comes void setup. Okay, inside void setup, I need to declare things. There is serial begin, the baud rate I have declared. And inside this only I have giving you the for loop. See, I equal to 0, I less than 15. Okay, I plus plus. What is it? Like what we need to do these many times? These are the conditions for loop. What we need to do inside curly brackets, serial.println Arduino. That means this operation, this printing Arduino, okay, printing the word, okay, this need to go according to the for loop. I hope it is clear. I hope you have understood it. Okay. This is how we can write the for loop. This will be the output. We could have done it by only using the println, serial.println, by printing it 15 times. Okay. 15 times still you can print, but what if we need an output not 15 but 15,000 times? You cannot print it. Okay. So you need to give the condition in a for loop and it will get printed. Okay. Great. Let us move further. Use a multiplication increment. How to do that? Same. Change the operator. That's it. The multiplication increment in the for loop will generate a logarithmic progression. Okay. People who don't know logarithmic progression is, do not worry. Okay. Just focus on the code and how to write it, or basically how to use it. Int x, we've initialized void setup. Inside void setup again, given the rate and what in the for loop, x equal to 2. So x is beginning from the value, the number 2, x less than 100. Okay, so it will go up to 98, 99, but not 100. Okay. Now what is the condition? X equal to x into 2, that is x multiplied by 2. Understood? That means multiplication by 2 is happening. Okay. So x initializes from the value of 2. So the first will be 2. The second will be 2 into 2, 4. Again, the third will be 4 into 2, 8. Like this, it will happen. Understood? See, this is what's been going on. It will go on and on until the value 100 is reached. Okay, but not 100 because only less than is given over there. Okay, all right. I hope you have understood it. It's very simple examples that I've given so that it stays in your mind basically. Okay, let's move further. We can also declare the int data type directly in the for loop. How? We can just directly do this for int x equal to 2, x less than 100, x equal to x multiplied by 2. That means previously we used to just start writing from x equal to 2. But now what we're doing, we're writing int x equal to 2. That means we are initializing the integers here on. We don't need to initialize it outside. Okay. If you want to initialize it outside, it's absolutely okay. No problem with that. All right. If that is a constant value component or something like that. Okay. No problem with that. But this makes your code a bit shorter. Okay. And a bit smaller, a bit less complicated to operate on like that. So you can use this also. Now, what we're looking at. So in this code example that you've seen, if you see clearly, this code is basically to fade an LED. Okay, the here fade means like if you just don't want to turn it off and you want to dim it continuously so that the brightness becomes lower. Okay, that's what fade means over here. So constant int we have declared over here, that is pin PWM. Now, what is PWM, dear students? Pulse width modulation. Now, we don't need to worry about these things because in our future classes, we will be studying these in great details. Okay. So PWM pin, that is pin number 11, has been selected for this purpose. Okay. We have initialized the PWM pin over here. Okay. Then in void setup, what we are doing, we are giving the baud rate, declaring the baud rate first, and then inside the void loop, uh, we are declaring the integer, that is x equal to 1. And for int I equal to 0, I greater than -1, I equal to I plus X. Okay, try to understand this. Now we write analog write pin PWM I. Okay, so I equal to 2, 3. Fine. That's the range of analog value that we can give over. X equal to if I equal to is 255, X equal to -1. Okay, this will switch the direction at peak. We can delay it for 10 seconds that we have done over here. The lesser the time, the more fading effect can be seen clearly. Now, what is happening? Because the value is, can you see, is decrementing. And due to that, the more the less the value of delay we give between two laps, okay, the more continuous it happens. Try to understand, if we delay it too much, it would result in somewhat discontinuity, right? So the more value we give to the less value we give to delay, okay, it will act like that. I hope you understand. All right. Okay, this is what the code is doing over here. All right. See, for the connection, we will connect the positive terminal of the LED in series with the resistor to pin 11, that is PWM pin, and the negative terminal of the LED to ground. Okay. Understood? Because we have selected pin number pin 11 over here. That's why we are connecting like this. Series code is an easy one, okay, with a good example. Very easy. Try to understand. First, in void setup, what we have done, we have declared int I, that is we are declaring or initializing an integer. And after that, we are declaring the baud rate over here, right? The standard rate 9600. Now we are initializing the for loop, that is I equal to 0, I less than 4, I equal to I plus 1. Simple. Okay, from 0 to 4, like 0 to less than 4, I will be incremented by 1. That's it. Now serial println, hello Arduino. This is what we need to print. And then serial println done. So after the loop has been executed fully, we want to print done. Okay. This is a one-time run code. So we are not declaring, or we are not giving anything to void loop. All right. Okay. So this is the case. I hope you understand. What would be the output over here? This would be the output. See, we are printing hello Arduino. How many times? We are initializing I equal to 0. Then we are incrementing it I plus 1. So 0 plus 1 is 1. Then 1 plus 1 is 2. 2 plus 1 is 3. 3 plus 1 is 4. But it cannot be 4 because it should be less than 4. Right? And after this is done, see, this is inside the for loop, inside the brackets of for loop. So after it is done, we will be printing. See, it is outside the bracket, serial println done. So we will be printing the word done. See, so 4 times it has been printed, and done is printed after it came out of the loop. I hope you have understood this. Okay. So again, a very short repetition of what we have studied from this code itself, I can say. So in this session, what we have studied is about for loops, right? So what does for loops? Loops means when you are about to run the program continuously again and again, right? So what we are doing first, we are initializing a condition. Okay, I equal to 0. Then what we are doing, we are saying I less than 4. That is, our first is the beginning, second is the end. This is how you need to remember. You can remember like this. First is the beginning, second is the end, and then comes the increment. How is the incrementation done? Okay, I equal to I plus 1. This is how we are incrementing it. All right. I hope you understand. Okay. So this is what we have studied in today's session about for loop. Okay. I shall meet you again in the next session. Till then, revise everything that you have studied in all the sessions, and do not forget anything. You don't need to memorize or remember as such. Just keep practicing the codes, and try to implement or try to apply all the knowledge that you have gained from our sessions. Okay, we shall meet you in the next session. Thank you very much, students.